We just talked about how authentication works on the web. So the second security concern we talk about is really confidentiality. Okay, so what is confidentiality and how are we making sure of that? Okay, so the confidentiality concern comes from the fact that on the web we want to visit multiple websites that don't necessarily trust each other. So some of these sites we may trust more than the others, and we certainly want to make sure that anything sensitive or personal that we give to one site is not going to find its way to another site. Okay, and this is primarily handled using the same origin policy. So the same origin policy partitions the domain, the web into domains and isolates, sensitive data based on the domain to which it belongs. So in particular, what we want is we want to be able to, visit a website that could be malicious and we should be protected. And we want to visit two websites that may be that may not trust each other, or that one of them may be trying to steal some information from the other. And we want to be safe in that case. And we also want to be possible for one website, a.com, to provide content that includes something from b.com. And and again, even though A and B may not be trusted, may not mutually trust each other, we want things to be safe, and we want things to be isolated. So what is the SOP? The SOP partitions the web into domains, right? So the domains are based on, we are talking about the same notion of domains as the domain name system. So what we want to make sure is that anything that belongs to, for instance, apple.com is not going to go to microsoft.com and vice versa. Okay. So what are the sensitive data that we want to protect? So one of the most important things we have talked about is cookies, because it's used for capturing things like login credentials. And in addition, the web page itself may contain sensitive data. If you go to your bank, the bank is going to give you information that is sensitive, and you want to protect that from other sites. Okay, and the same way, the data that you send and receive from these sites on the network. So again, that you want to be confidential. So the SOP is concerned with protecting all these types of data. Cookies is an example of data that resides on the browser, and then there is page content, and then there is network content, right? So we want to protect all of that. So when it comes to cookies, the policy, the way SOP works is quite simple. So each domain is associated with a set of cookies. So whenever a domain sets a cookie, it's put in that, it's associated with that domain, and only that domain can, access that cookie from that point on. Okay. In addition, whenever you contact that domain, the browser is going to automatically send those cookies, the cookies that belong to that domain, right, that are set by that domain, they are going to be sent back to that website. Okay, so this is how SOP works for cookies. So if you have a cookie set by a.com, then b.com cannot access that cookie. Okay. In addition, there are special type of cookies called HTTP only cookies. These are cookies that are not accessible from JavaScript. And later on we will talk about cross-site scripting attacks. And in cross-site scripting scenarios, one of the things that's often done is that a session cookie is stolen and sent to the attacker by an attacker script that somehow has gotten into a legitimate page. So by making the cookie as a HTTP only cookie, meaning that the JavaScript cannot access it, then that makes it, this type of attack, won't work anymore because the session cookie is no longer available, right? So there are these HTTP only cookies for that purpose. Okay, so now that we talked about how cookies are protected, let's talk about how page content is protected, right? So the way to protect page content, you have to define some, unit where, some boundary. And the boundary on web pages is given by the frame tag, right? So in a web page, typically consists of multiple frames, and each frame loads content from some domain, and we associate that domain with that frame, and then only that domain is able to access content of that frame. Okay, so meaning that if you have a frame that is that contains content from a.com, then any of the scripts in that frame can access all of the DOM nodes within that frame. But if you try to go outside of that frame to an ancestor frame, then that access will be denied unless the ancestor also belongs to a.com, right? So if the ancestor is b.com, then this access won't work. And by the way, what this refers to is the frames of zero, refers to the ancestor frame of the current frame. Okay, so you can't navigate to the ancestor unless the current frame belongs to the same domain as the ancestor frame. So this way, if you have content from a.com on one frame and b.com on one frame, the script in b.com cannot simply walk up and go into a.com's data, because the moment it tries to go out to navigate to a.com's frame, that access will be denied. So finally, in addition to protecting the content of pages, you want to make sure that the data that is sent or received over the network is not going to be available to scripts, except within their own domain, right? So, but before we start, we should be again, remember that the outgoing requests that scripts make is not limited in any way, right? So scripts can send requests to arbitrary sites. So if you have a.com, a.com can send a request to b.com, and there is nothing that prevents that, okay? Now, what happens usually is that if, let's say, a.com sends a request to b.com, then b.com is going to respond. And what the SOP makes sure is that the data coming back from b.com, okay, cannot be seen by a.com. So the way this whole thing starts is that there is a script on a.com's frame, and this script may submit something to b.com or make a request to b.com. The moment this happens, that frame is, the existing frame is, goes away, and what you have in its place is a new frame that contains the response from b.com. And this response, because it's from b.com, is going to be associated with that with the b.com domain. Therefore, even though A is able to submit a request to B, A is not able to look at the response. So any sensitive data that B sends back is not going to be visible to A. Okay, so that way, even though outgoing requests are not constrained, the confidentiality is still ensured because A cannot look at the data from B. Okay, so the question you may have is, is it always safe for A to send requests to B? And later on, we'll talk about, CSRF attacks, which exploit this fact to carry out an attack. Okay, so the model where we said, when A sends a request to B and the response, is no longer available to A's page, that is, normally true, but there is a special case of what are called XML HTTP requests. So these requests are used in the context of, what you may have heard of as, Web 2.0 applications. So these are applications that where you have a script running on a page, and this script dynamically constructs the web page. So this is something that you often see when you go to many social networking sites. So for instance, if you go to Facebook, it shows you one page of content, but if you scroll up, then you're going to get more content, and as you keep scrolling up, the scripts on that page keep contacting Facebook, and they get more and more data and they display. And this happens using this XML HTTP request, also called as XHR. And in order for this to work, the script that's fetching and showing the data should continue to operate. And so, for XHR, the way it works is that it's like a network query. You send a query and then you get a response. And in order to make sure that SOP is still enforced, XHR is permitted only to the domain associated with the same page. So for instance, if A.com is on the current frame, then A.com can do a XHR to its own domain, right? So it can contact A.com, but it cannot do an XHR to B.com. So this way, even though the data comes back, the confidentiality is not violated. So there are, a few caveats with SOP, and one of the most important one is that if you embed some content, so let's say A.com includes a script from B.com, right? So basically A.com says, there's a script tag, and it gives the source of the script as B.com. Now, the way SOP works is that this script, even though it's being downloaded from B.com, because it's embedded in A.com's frame, it is given all of the privileges of A.com, right? So this is something to keep in mind. So if you write a web application, and if you're going to include, a script from a different domain, you need to remember that even though it's from a different domain, it's going to have full access to your own data. Okay, so the situation is very much like so the situation we described here is very much like a user A running an executable written by B in a Unix environment. So notice that even though the executable was written by B, it's going to be run with the privileges of A, and that's exactly what we are seeing here. Okay, so there are some exceptions that are made to same origin policy as a trade-off between functionality and security, and the most notable ones are in the context of style sheets. You may know that style sheets are used to make it easy to control the formatting of a page, so that you can in one place define how all, say, bulleted lists look like and how all tables look like. So you don't have to specify within the HTML for each table and each bullet list on each other element of the page exactly how it is to be rendered. Instead, you can use the style sheets to sort of say how all bullet lists and all tables are going to look like. So in the context of CSS, some relaxations are made, and normally these relaxations, it is assumed that these relaxations don't reveal much sensitive information, and that may still be true to a large extent. But attackers are resourceful, and they often find a way to get at sensitive data in a setting where we thought no sensitive data was being exposed. So over time, the SOP is tweaked to sort of address some of these attacks. But you should, so the point that you should keep in mind is that there are some exceptions, and you should be aware of those exceptions and look them up at the time you say write a web page. So SOP is a very simple and good and clean policy that provides a foundation for confidentiality or pretty much all of web security, but it's not without its limitations, right? And the very fact that it is simple also generally means that it's going to be rigid, and in particular, it is an all or nothing approach. Either when you have a situation like the example we've been talking about, A.com and B.com, we say that A.com has full access to its own data, whereas it has no access to B.com's data, right? So it's an all or nothing approach. And this is not always very convenient. And one example we talked about is when A.com wants to include some code from B.com, and we said this code is going to run with A.com's privileges, and this may not be what you would like, but there is nothing that the SOP can do to help you. So the second limitation we talked about is that A.com can make a request to B.com, and this can sometimes be used in attacks. So you need to be mindful of these limitations of SOP. Okay. So in addition to ensuring confidentiality between mutually untrusting sites, you also want to make sure that visiting a malicious website doesn't compromise your browser or your operating system. And this is ensured by the fact that JavaScript itself is a safe language, and the browser provides only very limited access to the local resources on your computer system. Okay, so this is how we get confidentiality for the operating system resources. And finally, we want to talk about integrity, because that's another important component of security on the web. So we have to talk about integrity of two types of data that is transmitted on the network and the data that is held inside the browser. For network data, we primarily rely on encryption, basically HTTPS, which in turn relies on SSL or TLS, as you may want to call it. And that's what ensures both confidentiality and integrity of the data. And and we have already talked about how public key protocols are used to, or in particular, public key certificates are used to establish a secure session with a server. When it comes to data that is within the browser, then the integrity of this data is all protected using by the SOP, because SOP not only limits read access but also write access. So if only A can write its data, well then A's the data of A its integrity is assured, at least when it comes to threats from other domains. So B.com cannot really affect the integrity of the data belonging to A.com. Okay. Now, So the SOP is there, and it forms the underpinning of the security of the web. Although it is there, doesn't mean that we have solved all the problems, and there still remain many attacks that are possible by exploiting vulnerabilities in the way web applications are implemented. Okay. So we will organize these attacks into 3 groups depending upon the threat model, right? So the threat model, which if you remember, the threat model captures the capabilities that the attacker needs. So the one class we'll talk about the most is the web attacker. A web attacker is sitting somewhere on the web. The web attacker has no access to the local network of the user or the local computer of the user. Okay, so just sitting out there on the web, they are able to carry out the attack. The second case is the network attacker. The network attacker is sitting on the local network or in between some web server and the user. And by using their vantage point, they are able to carry out attacks. And finally, you have this malware attacker, which is a case where the attacker is either the browser or the browser user. Okay, so we'll talk about all these 3 cases in the next few slides.